So now in this video, we're going to look at the 555 timer. I'm using an NE 555, a UA micro A 555 should work the same. But in any case, it's wired in astable mode. So astable basically means no stable. There's no stable mode to this. You're going to see the blue and red LED output going high and low. Low when the blue LED is lit, high when the red LED is lit. You're going to see it alternating forever, as long as nothing goes wrong with this circuit. There's no stable state. I don't have to do anything. It just keeps going back and forth. The speed is set by the capacitor and two resistor values right there. They're not adding up to set the timing at any point. The capacitor charges through one resistor because I have this diode right there. If you don't have the diode, then it charges through the two resistors, but it charges through one and then it discharges through the other. So if you want a longer period of time where the output's high, longer period of time where the capacitor charges to 2/3 of the supply voltage, you can just get rid of this diode and add up that resistance, and then the output's going to be low through the one resistor. So that's going to set the time. With a 10,000 ohm of resistance, 100 microfarad capacitor, it's going to take about a second to charge. That's when the output is high. And then same with discharging. When you discharge through a single 10K resistor, if you have 100 microfarad capacitor, it's going to take about a second to go from 2/3 to 1/3 of the supply voltage. Pin 6 and pin 2 monitor that. So that's the discharge pin, pin 7 going to ground. The output is pin 3. Off to the left there goes 1, 2, 3, 4, 5, 6, 7, 8. And we have pin 4, so I don't forget right there going to ground. That, or going to the positive supply. Sorry about that. Positive supply. That disables it. Pin 4 is just waiting for a low input. Pin 6 is waiting for a high input, 2/3 or more of the supply voltage before it does something. And pin 2 is waiting for a low input, 1/3 or less of the voltage. If either of these pins, any of these pins, don't get the voltage they're waiting for, then they don't do anything. They're just waiting. And so that's something to remember. And they don't let current in or out. That's pretty typical with inputs of integrated circuits. Not all of them are bipolar junction transistor based where some current will go through. Usually they try to stop current going from the inputs when they make the integrated circuits. And so we could use a lower value capacitor to go faster, but that wouldn't make for a very interesting video. 1 second seems to work pretty well. And we could use lower value resistors, or we could go higher in value as well. And so you can adjust them as desired. We have the, since I'm going to talk about the schematic so much, let's zoom in a little bit. We have the blue LED lights up when the output's low. That's a direct connection to ground. I've covered this in other videos. Blue LED is brighter, plus we got more voltage. So I have a higher value resistor, 1000 ohm resistor. When the output's high, that's when the red LED lights up because we got the positive supply. But the transistor is used to switch that, drop some of the voltage. As I said before, these integrated circuits, some of them depend on bipolar junction transistors built into them, which drop some of the voltage in certain situations. And so just be aware of that. This is a single supply component. That means we got ground as the negative supply, 0 volts, where ground is. All the other voltages are more positive. They go up to 5 volts in this case. That's what I have my power supply set to. The 555 component can handle more voltage. I don't know the exact voltage. But in any case, if you're working with higher voltage circuits, you got to look at the limitations of all your components. Make sure you're not exceeding any of them. Same with current. So, in any case, whatever the supply voltage is, the output is going to drop about 1.5 approximately, maybe 1 volt if there's no load it's powering. Maybe it's just sending a signal to other inputs, like I said before, that don't let current in or out. All kinds of ways you can wire this up. This is just one of the 3 main ways, the astable mode, where it alternates. I'm flashing LEDs. You can do all kinds of other stuff with it. First off, I was mentioning with the monostable mode, that when I pressed a button, the output was high for a period of time while the capacitor charged. You know, if you need a longer period of time, it actually works better for astable than monostable. The monostable one wasn't the best one to mention that. But you can get a counting integrated circuit right there. And you can wire it up where it will count 10 times. If you want more than 10, like you need another counter, just like you can go from 0 to 9, and then you can add another digit where you can go 0 to 9 on one, and then it makes a 1 on the one next to it, 0 to 9, and then 2, and so on. You can have counters. So instead of trying to get a really large value capacitor that takes a long time to charge because it will have leakage going through it, at some point the low current to try to get it to slowly charge will stop its charging. It'll be getting current in, but it'll be passing through. It'll be leaking through. There's a certain period of time where you can, keep raising the voltage at a low current before what slips through starts affecting it. So you can send that to a counter. So you could do like maybe 30 seconds pretty accurately on here, and then send it to a counter that does that 10 times before you pass along the signal to something else, and then it'd be 300 seconds. So just wanted to mention that really quick. We have the two inputs that are looking at the voltage, so they are tied together, as you can see right here. There's no outside influence for just the basic astable 555 timer. You could add it to, get more effect than what we got here, but now we're just limiting it with the basic circuit. As I said before, 1000 ohm positive supply, so you can tell the blue LED lights up when the output's low connected to ground. With the red one, you can see its resistors to the negative supply. So it has to get voltage from the positive supply and pass that along. Remember, there's transistors, though, that drop some of the voltage. But there you can see how it lights up. And I already talked about the resistor values, plus in other videos. So this is to the positive rail there. Now, this is a direct connection to the positive rail as well. So if you want to kind of limit space, you can just put that resistor where the pin number 8 comes to the positive supply, top pin there. But it comes down one row, and then we got another 10K resistor, but we got this diode. So gray band there is pointing at the capacitor. So that's the direction that it conducts easily. And so with the low voltage that it takes to get it to start conducting, plus that resistor right there, basically you get about the same amount of current flowing into the capacitor as if these two components weren't there. But when it discharges now, the capacitor will be more positive. The output, pin 7, will connect to ground. And so the capacitor cannot discharge through that diode. It has to do all its discharging through this 10,000 ohm resistor right there to pin 7. One more pin down. I know it's kind of hard to see. I don't think it's kind of cramped, so I don't think there's any way I can make a really easy way to see it without devoting a ton of time to it. In this video, won't get enough views to go through all that, so I'm going to keep it simple. But in any case, there is the schematic, and I think I covered pretty much everything that goes with this circuit. Of course, there's ways to modify it a little bit, as I said before. Using lower value components will get you a quicker timing, and higher values will take longer. You can also go to just do a Google search of Astable 555 calculator, and then you can enter the numbers you're working with, like the voltage, which doesn't really affect the timing so much, but you can enter the numbers that you desire for whatever reason, like the frequency and the capacitor you're using, and then it'll tell you like what resistors to use in that case. So you just enter the numbers and it will display what you need, as long as you have the right numbers entered for what you are working with. But you can also just do trial and error. I did this in the last video with the monostable. That one, the output was low until you press the button and it goes high. Otherwise, so this is for the load, but for the timing, you can just swap out the resistors and capacitor. As long as you don't, well, with this one, you can't really go too big with the capacitor unless you have too little resistance. Remember, the current of the discharging capacitor has to go through the 555 timer. So high period of current for a period of time, high current for a period of time will, you know, damage the component, as it always will. So just be aware of that. But for the most part, you can go with about as large of a capacitor as you want, because you're using resistance to limit the current. Just, you know, keep it below like probably 10 milliamps or something. You should be fine. But in any case, you can adjust the values, and you can just do that. I can pop these out right now. It won't damage anything, and reinsert them as long as they don't miswire anything. It is better to turn the power off, but you can swap components really quickly. And if it starts going too fast, then you just use a higher value component, and it will slow down. You know, it's that simple if you don't need a precise timing. So in any case, that's it for this video. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.